Noise originating from the rear of a car must be carefully analyzed to determine the source before attempting to perform any repairs. An evaluation must be made to determine whether the complaint is valid. Let's look at some of the things that affect the noise level and why it differs between models. Noise level within the passenger compartment is influenced by such factors as vehicle length, body style, body construction, and tire types. Since the Vega is a subcompact vehicle, the noise level heard in the passenger compartment will be somewhat higher than that of the larger luxury Chevrolets. After an accurate and clear repair order has been written, the vehicle should be road tested to isolate the noise. The rear tires can be eliminated as a noise source by driving over different road surfaces. If the noise remains the same, the problem is not the tires. Tire problems can also be isolated by increasing tire pressure. If the noise level is considerably reduced, you've got tire problems. Rear wheel bearing problems can usually be recognized by a growling type noise during both a drive or coast condition. To locate which wheel bearing, turn a corner to place a side load on the outside wheel bearing. Should the noise be present while turning in one direction but not in the other, you've located the bearing. Differential side bearings will produce a constant low-pitch growling noise. Pinion bearings, on the other hand, will produce a high-pitch whirling or scraping noise. Remember that the pinion bearings are rotating about 3 times faster than the side bearings. Ring and pinion gear noise will tend to peak in a narrow speed range somewhere between 45 and 55 or 60 to 70 miles per hour. This high whining noise can be varied by changing the throttle position. A decision must be made during the road test as to whether the noise is acceptable for a vehicle of this type, because it has been noted that the Vega tends to have a higher interior noise level than the luxury Chevrolets. It may even be necessary to compare the noise level against other vehicles of the same type. For those instances where your diagnosis indicates an unacceptable noise level, and the noise is not the result of differential damage or malfunction, you should perform the following procedures. A service damper package has been released to the field which can help to reduce the amount of gear noise being transmitted into the passenger compartment. The package consists of a drive shaft damper which replaces the front yoke and 2 upper control arm weights. The drive shaft damper helps reduce the amount of noise vibration transmitted from the differential into the drive line. The control arm weights help prevent the arms from resonating at the frequency of the gear noise. The package shown here is installed on 1971 and 72 Vegas. Look for another package to be released very soon for 73 units. To install the drive shaft damper, remove the shaft and replace the front yoke with the damper. The upper control arm damper weights are bolted to the lower portion of the arms. The installation of the package is covered in Service Bulletin 72T29. If the gear noise level is still unacceptable after another road test, remove the differential cover and drain the lubricant so that a gear contact pattern can be made. The contact pattern must be checked to determine which adjustments must be made or whether it will be necessary to replace the ring and pinion. Clean the ring gear teeth and apply a thin coat of marking compound. With the parking brake partially applied to place a light load on the ring gear, rotate the ring gear through 1 complete revolution in each direction. A correct contact pattern is one in which the contact area is centrally located on the drive or convex side of the ring gear teeth. The outside portion of the gear tooth is referred to as the heel and the inside as the toe. A contact pattern like this that appears high on the tooth face is caused by the pinion being placed too far away from the ring gear. To correct this situation, the pinion will have to be shimmed in closer to the ring gear. Should the pattern be low on the flank of the tooth, the pinion is too close to the ring gear. It will be necessary to reduce the pinion shim thickness in order to place the pinion farther away from the ring gear. A contact pattern that's concentrated at the toe of the gear is caused by insufficient backlash. To increase backlash, shim the right side of the differential case, while decreasing the shim thickness an equal amount on the left or ring gear side. This will move the ring gear further away from the pinion. If the pattern appeared on the heel side of the gear, it indicates excessive backlash. To decrease backlash, shim the left side of the differential case, while decreasing the shim thickness on the right side an equal amount. If the correct pattern would overlap the old pattern, it will normally be necessary to replace the ring and pinion gears. Exceptions are if the vehicle has very low mileage, or if the gears were very recently replaced and a pattern check reveals improper adjustment. The latter situation, of course, points out the need for always performing the final pattern check after servicing. If a decision is made to attempt adjustment of low mileage gears, and the final pattern check shows a poor or broken contact due to the pattern overlap of the previous improper adjustment, the gears must then be replaced. Whenever the ring and pinion gears are replaced in a differential, the pinion depth, pinion preload, side bearing preload, backlash, and the gear tooth contact pattern must be re-established so that the gear set will provide satisfactory operation. At this time, we're going to cover the replacement of the Vega ring and pinion along with the adjustments. The tools and equipment you will need to service the differential include the companion flange holder, remover, and installer, pinion rear bearing remover and installer, side bearing puller and installer, axle shaft bearing remover and installer, sliding hammer, pinion front bearing and oil seal installer, side bearing bore plug, a 100 thousandths dial indicator set, foot-pound and inch-pound torque wrenches, pinion depth gauge, hypoid gear lube, and gear marking compound. A listing of the tools and equipment, along with the special tool numbers, can be found in the reminder booklet. Greater access to the differential can be obtained by supporting the car body, possibility of damage, thus allowing the carrier to drop down to its lowest position. Free, remove the caps. The muffler and tailpipe can be removed. Be sure to mark the caps additional room so that they can be reassembled correctly. Remove the drive shaft. Remove the cover screws to begin the pinion and drain the fluid. Then remove the cover. To remove the axle pinion flange, first unscrew the special holding tool with the notches toward the pinion shaft. Then remove the pinion nut and washer. With the axle shafts pushed align inward, the pinion flange puller notches with the holder. Now the shafts can slide the puller through the holder. The pinion shaft and notice that the notches go towards the holder to retain the pinion gears. Now, loosen the bearing caps, but don't remove them yet. Use caution when prying the differential case from the carrier. The use of a wooden block between the pry bar and the carrier will greatly reduce the possibility of damage. After the case is free, remove the caps and case. Be sure to mark the caps so that they can be reassembled correctly. Remove the drive shaft to begin the pinion removal. To remove the pinion flange, install the special holding tool with the notches toward the flange. Then remove the pinion nut and washer. Align the pinion flange puller notches with the holder and slide the puller through the holder. Notice that the notches go towards the holder. Now rotate the puller 1/8 revolution and turn the bolt clockwise to force the pinion flange off the shaft. Drive the pinion shaft out of the carrier using a hammer and drift. The cover should be installed with a couple of bolts to keep the pinion from falling out of the back of the carrier. Then pry out the pinion oil seal. Next, thoroughly clean the carrier to remove any metal chips or filings. The axle tubes should also be cleaned to remove any metal particles. An atomizer filled with solvent works well for this job. Since the pinion bearings and races of this unit appear to be damaged, they will have to be replaced. Use a drift to drive the races out of the carrier. To begin the reassembly, install the new pinion bearing races using the special tool bearing installers. To determine the shim requirement for obtaining the correct pinion depth setting, install the special tool gauge plate, preload stud, and the rear pinion bearing into the carrier. In this case, we're using new pinion bearings since the original bearing had to be replaced. Be sure to lubricate the bearings with hypoid lube. Next, install the front bearings, pilot, and hex nut. Tighten the nut snugly and rotate the bearing to make sure the gauge plate is properly seated. Tighten the nut until 20 inch-pounds of torque are required to rotate the assembly. Then, install the arbor cross shaft and side bearing discs into the housing. With the bearing discs seated, install the bearing caps and tighten the bolts finger tight to prevent the discs from moving. Install the dial indicator on the mounting post so that the indicator makes contact with the end of the plunger. The plunger must not be contacting the gauging surface. Depress the indicator to preload it approximately 1/2 revolution. Then, tighten the clamp to firmly position the indicator to the mounting post. Now place the plunger in contact with the gauge plate and slowly rock the cross shaft so that the plunger travels across the gauge plate surface until the indicator registers the highest reading. Perform the operation several times to locate the exact point. Then set the indicator at 0. Then rotate the shaft so that the plunger moves off the gauging surface. The indicator will register the required pinion shim thickness for a standard size or nominal pinion. In this case, it's 28 thousandths. Be sure to write this number down. To determine the correct pinion shim to be used, check the rear face of the new pinion for its code number. Most pinions used as service parts are standard size. If the pinion has a plus number, it will be necessary to add this amount to the indicator reading. A negative number means that it will be necessary to subtract the amount from the indicator reading. Previously, the rear of the pinion was marked with a number from 40 to 50 to indicate its relationship to a standard size. The number 45 represents the standard size. In our case, since the pinion number represents a -1 number, it will be necessary to subtract 1/1000th from the 28 thousandths indicator reading. A 27 thousandths pinion shim will be used to position the pinion. Pinion shims are available from 21 to 37 thousandths in 1/1000th increments. Remove the pinion depth tools and pinion bearings from the housing. With the correct pinion shim placed against the pinion gear, install the rear pinion bearing using the special tool. Next, slide the new bearing spacer onto the pinion. Also, lubricate the rear and front bearings before they're installed into the housing. Before installing the new pinion oil seal, lubricate the cavity in the seal with a chassis lubricant. After the front bearing has been placed into the carrier, tap the pinion seal into place using the seal installer tool. The spacer tool should be placed behind the seal during installation to make certain the seal is installed to the correct depth. Next, install the drive pinion in the carrier. Position the companion flange on the drive pinion and use the flange installer to force the flange onto the shaft. After the flange is seated, remove the tool. Apply a non-hardening sealer to the rear face of the washer to prevent the gear lubricant from leaking past the splines on the pinion. Then, install the washer and pinion nut. Tighten the nut until all the end play has been removed. The preload is being neared when the holder will no longer pivot freely. Now, carefully set the preload to 20 to 25 inch-pounds for the new bearing. Used bearings are set at 10 to 15 inch-pounds preload. As the rotating torque specification is being neared, tighten the pinion nut in very small increments. Should the preload be exceeded, it may be necessary to replace the collapsible spacer. Rotate the pinion several revolutions and recheck the preload. If it's fallen off, reset it to the specification. To remove the damaged ring gear from the differential case, remove the ring gear bolts. Use a soft mallet to drive the gear off the case. After the ring gear has been removed, inspect the case flange surface for nicks or embedded foreign material. After this area has been cleaned, lubricate it with hypoid lube to aid the installation of the new gear. Also, inspect the side and spider gears for any signs of damage. After the ring gear has been started onto the case squarely, install several of the bolts around the diameter of the gear and draw them up evenly, using a crisscross pattern to firmly seat the gear. Next, reinstall the remaining bolts and lock washers and torque the bolts to specification. Before installing the differential case back into the carrier, be sure to inspect the bearing cups, and seats for any signs of nicks, burrs, or foreign material. If any of these conditions are present, they must be corrected before the case is reinstalled. Lubricate the side bearings with hypoid lube, then place the bearing cups back on their proper bearings. Next, reinstall the case back into the carrier. Support the case to prevent it from falling out of the carrier. To establish the side bearing preload requirement, rock the ring gear back and forth while forcing it in the direction of the pinion. This will remove all of the backlash. Place a 160 thousandths service spacer and a service shim between the bearing cup and the carrier on each side. Ensure that the bearing cup is positioned fully inboard and is parallel with the carrier boss. Now, select a feeler gauge that will produce a slight drag as it's drawn between the carrier and service shim. Leave the feeler gauge on the left side and use another feeler gauge to determine the clearance between the shim and carrier on the right side. Now, add up the thicknesses of the spacer, shim, and feeler gauge used on the left side. In this case, the total thickness was 241 thousandths. The total thickness on the right side is 229 thousandths. Now add 4 thousandths to each side in order to obtain the correct preload. To establish the proper backlash between the ring and pinion, subtract 10 thousandths from the left side shim requirement while adding 10 to the right side. This will move the ring gear away from the pinion 10 thousandths, which should result in a backlash reading of 5 to 8 thousandths. The total left side shim thickness should be 235 thousandths, while the right should be 243 thousandths. Because the production preload shims are cast iron, they shouldn't be reused, since they can be easily broken during installation. Service shims are available in increments from 64 to 100 thousandths of an inch. Install the left shims first, and then use a mallet to tap the right shims into position between the bearing cup and spacer. Place the chamfered edge of the shim against the spacer. It may be necessary to file or grind additional chamfer on the shims to help the installation if the original chamfer was not sufficient. If difficulty is encountered while trying to install the shims, place the shims in position and drive the differential case into the carrier. If undue effort is encountered while attempting to install the case, it may be necessary to slightly reduce both right and left shim thicknesses equally. After the shims have been installed, reinstall the bearing caps in their proper position and torque the bolts. To check the backlash between the ring gear and pinion, position a dial indicator so that the contact button is at a right angle to the tooth of the ring gear and in line with the gear rotation. Check the backlash at 4 locations equally spaced around the gear. Move the ring gear back and forth while holding the pinion flange. The measurement of this clearance is referred to as backlash. If the variation between any of the measurements is greater than 0.02, then relocate the indicator and measure the ring gear and case runout. Should this be more than 0.03, check the ring gear and case for warpage and for possible foreign material between the case flange and the gear. Getting back to the backlash measurement, it should be between 5 and 0.08 of an inch. If the backlash is excessive, the shim thickness on the ring gear side must be increased, while the shim thickness on the opposite side must be decreased an equal amount. The backlash will be changed about 0.02 for every 0.03 change in shim thickness. Should the backlash be less than the specification, it will be necessary to decrease the shim thickness on the ring gear side and increase it on the opposite side an equal amount. Remember that as long as the shims are moved from side to side in an equal amount, the side bearing preload will remain the same. With the axle shafts and brake drums reinstalled, partially apply the parking brake. This will place a load on the ring gear so that an accurate contact pattern will be produced. The contact pattern must be established to assure quiet operation and long life of the gears. 20 to 30 foot-pounds of torque should be required to rotate the pinion. If not, adjust the parking brake accordingly. The amount of load placed on the ring gear affects the size of the contact pattern. Clean the ring gear teeth and apply a thin coat of marking compound to the teeth. Then rotate the ring gear 1 complete revolution in each direction. Our contact pattern here is correct. Notice that it's centrally located up and down on the face of the ring gear teeth. If the pattern had been incorrect, it would have been necessary to go back and make corrections to the backlash and pinion depth adjustments. Now reinstall the C-locks on each axle shaft and push the shaft outward until the lock seats in the counterbore. Also wipe the marking compound from the ring gear. With the pinion shaft reinstalled and the hole aligned, reinstall and torque the lock bolt. Install the carrier cover with a new gasket and torque the bolts in a crisscross pattern. Then refill the carrier with hypoid lube. Also reinstall the drive shaft, muffler, and tailpipe. At this time, let's review the differential adjustments. In summary, the amount of noise heard in the passenger compartment is influenced by such factors as length of wheelbase, body style and size, body construction, and type of tires. We cannot overemphasize the importance of becoming familiar with the noise characteristics of particular models, so that an accurate judgment can be made as to whether the noise level is acceptable. Since the Vega is a subcompact, the noise level heard in the passenger compartment will be greater than that of larger luxury Chevrolets. Once a noise is determined as unacceptable, the problem should be isolated and located during the road test. If the gear noise level is higher than normal and is not the result of differential damage or malfunction, the damper package should be installed. Then road test the vehicle again to determine if the noise has been reduced. If the gear noise is still unacceptable, check the contact pattern. Adjust or replace and adjust as necessary, depending on whether or not the old contact pattern had worn into the gear. Whenever the ring and pinion are replaced, the pinion depth, pinion preload, side-bearing preload, and backlash must be reestablished. The contact pattern should also be checked to make sure it's correct. If these procedures are performed correctly, satisfactory operation of the differential can be assured.